Good morning, everyone. Today we're going to have a look at the product rule, and then in my second video, I'm going to go through the quotient rule. This is an exercise of 6 questions, I think, and there's not really much practice on these two really important skills. Okay, product rule. So key thing here is this bit here. It says, when differentiating a product of two functions, it is not possible to differentiate the two functions separately and then multiply. Okay, so they give you a little example here, and let me just make some sense of this to start off with. Now, normally we're used to doing something like, I don't know, if we get 2x cubed plus 4x squared. If you have the addition of two functions, here we go, here's a function, here's a function, we definitely do differentiate one of these things. So this one becomes 6x squared, and this one over to the side, the other one becomes 8x. So we definitely differentiate those two things and add them together to get our dy dx. But the example that they're giving in the book there is they're saying, well, check out this, for example, 5x to the power 4 differentiates to 20x cubed. Now, if we split that up, 5x to the power 4 into 5x and x cubed, and differentiate to those two separately, then we get 5 times 3 times x squared, which is not the same as this thing here. So when you have a product of two functions, you cannot differentiate one and differentiate the other and then multiply them together. So what do? Well, the thing you do is use this thing called the product rule. Right, let's just snap this thing here because I do it in a slightly different way. Okay, so this is the product rule. And they say, well, to find dy dx in this case, you're going to need to take the first of your functions. So I know, let's come up with a function u v, right? So what do I mean by that? I mean, say, for example, you could have x plus 1 squared as one of your functions. That would be your u, or your u of x, if you want to call it that, because it's a function of x, multiplied by, and I don't know, let's call this one, let's come up with something a bit different. Call this one sine of x, which we don't know how to differentiate just yet, but we will later. So these would be our two functions. They are being multiplied together in the middle. So we would say, okay, u of x is this thing here, x plus 1 squared, v of x is equal to sine of x squared. So they're saying, here's the product of two functions. Now, you could do this with the product of more functions, but we're going to stick with two at the moment. Okay, so they say, well, you take the first function as is and times that by the second function differentiated. And then you take the second function as is and times that by the derivative of the first function. Now, I normally write that down like this. That's u v dash plus v u dash. Okay, that's the same thing. So I'm saying v dash is the same as v dash of x, because it's a function of x, is the same as dv dx. It's all the same notation, just trying to keep things a little simpler. Okay, so we've got uv dash plus vu dash, and in this case, it doesn't matter if you forget which one comes first, because it would be equally right to say vu dash plus uv dash. That would just be this term coming last and this term coming first. Right, okay, well, so let's have a look then. So there's a bit of the theory there, or at least a bit of the technique. You don't need to know the proof, but the proof is pretty interesting. They talk about these limits again of functions, and I would really suggest having a look through this one, but I'm not going to go through it now. I'm going to go through the dynamics of this. Just to say there's a kind of interesting step here that when you go from this to this, they've added in this f of x plus h times g of x and subtracted the same thing as well, which is a nice little trick in order for them to split this thing into two separate limits and then bring out the f of x plus h and the g of x on the other side. And then actually this pops out pretty quickly. Essentially this is it, the product rule, apart from they've done it in terms of f and g rather than u and v. Okay, anyway, it's interesting. Have a look through that one, but you're not required for this to produce this in the exam or to know that proof. But you're also given this formula here. Okay, well, anyway, let's have a look at one of the questions. So here we go. Let's look at example 12. So example 12 here. Let's steal this thing here. Right. Okay. So first of all, the way I would lay this one out is to say, let's start by stating what U is, and let's start by stating what V is. So we can see that we've got, instead of calling it Y, they've called it f of x here, but same thing. So they've said that we've got U is equal to x squared plus 2x, or you can call that U of x if you want, and V is equal to, I'm just going to write it in the index form here. So x to the minus 1, because it's easier to differentiate, plus r3. Now I'm also going to write down, because I know I'm going to need to use these ones, u dash, so that's 2x plus 2, and v dash here as well. And that's going to be times by minus 1, reduce the power by 1, so minus x to the minus 2, and the plus 3 is going to disappear. Okay, so use the product rule. Well, we know what the product rule is. It's u v dash plus vu dash. Okay, so that's what we're going to be substituting into. So now we've got dy dx is equal to, so we've got x squared plus 2x, that's just u, times by v dash, so we've got minus x to the minus 2 there, plus v, so we've got x to the minus 1 plus 3 times by u dash here as well. And u dash is 2x plus 2. And that is fine, that is actually finished. But we might want to just manipulate this a little bit. So obviously you could take this thing down to the bottom. So you could take x squared plus 2x all over x squared. And we've got a minus there in front because it's times by a minus. And then you could multiply this one out as well. Let's just see what the book does actually in this case. So they've got my first line there as well. Ooh, they've done some serious simplifying to get to this stage, but that's just algebraic. And so they're going to have to times out this bracket here, this double set of brackets, and then simplify it all as well. Well, should I do that or not now? Well, let's take it a little bit further, okay? So if we times x, we times this by this, well, x to the minus 1 is the same as 1 over x, so that's just going to leave us with 2. And then if we do 3, well, we've got 4 things that can pop out here. But this times by this, so we've got 2 over x. And then we've got 3 times by 2x, so we've got 6x there. And we've got 3 times by 2 there as well, so plus the 6. Okay, well, again, I could take that a little bit further. I'm running out of space here, and I won't, and it's a good algebraic exercise to try and take it further. Just one thing, and that is that you can split this up into 2 separate fractions. So actually, minus x squared over x squared is minus 1, and then you can do plus separately, and then we've got minus 2x over x squared, and I think that's going to cancel with this term later on here. Okay, but that's where that one goes. Okay, so let's just take it on a bit further because there's another question coming up here. So let's have a look at example 13 before, and the next video I'm going on to the quotient. So example 13 next. Okay, and I think example 13 is going to need to use the chain rule in one or both of these as well. So let's snip this one. Now you might want to stop at this stage and have a go at this one yourself. Okay, but let's write this one down. So we've got u equals x squared minus 4 all squared, and we've got v is equal to x cubed minus 1 to the power of 4 here over to the side. Right, okay, and just before we're going to write down u dash, and we're going to write down v dash. And to remember, this is going to require the chain rule, and hopefully you've had sufficient practice with the chain rule now to make this really efficient. The chain rule says do essentially differentiate u squared, which is going to give us 2u. Okay, I just haven't written in u there. And we need to differentiate the function inside the function as well. So we're going to get out 2x is the derivative of the x squared minus 4. In other words, the derivative of u, if you like. And we should simplify that one as well. That's going to give us 4x x squared minus 4. And I'm not going to multiply out the brackets because I might need to factorize later on, and this might be a common term. I'm not sure. So I'm not multiplying out the brackets. And for the other one, again, we've got 4u cubed. Okay, so 4u cubed. And then times by the derivative of what's inside there, so times by 3x squared, minus 1 disappears. So that's the same as before. So we've got 12x squared and then x cubed minus 1 cubed. Okay, so we need to put this thing together. That's going to take some time. So we've got u v dash plus v u dash is what we're trying to do. So we've got x squared minus 4 squared times by 12x squared. So I'm going to put 12x squared at the front. Then we've got x cubed minus 1 cubed. And then we've got, that was, sorry, what was that? That was u, so u was there, and that was v dash, and that was that thing there. Okay, and then we've got to do the plus, so we're doing this part now. Okay, so v is equal to x cubed minus 1 to the power of 4 times by u dash, and u dash, oh, let me just take that back because it's not looking pretty. Okay, so we've got u dash is actually 4 x. Tell you what, I'm going to put the u dash first here. X squared minus 4, and then v. So x cubed minus 1 to the power of 4. Okay, so that's your dy dx. I should state that for the examiner as well to show them that I know what's going on. Okay, now you could see that you could factorize this further. You could see that you've got some common factors here. You've got x plus x squared minus 4 in both of these. You've got 2 of them on the left-hand side there and 1 on the right. So you could factorize out x squared minus 4. You could factorize out a 4 from the 4 and the 12. You can factorize out an x. Okay, we'll leave you with one of your x's there on the left-hand side. And you can also factorize out 3 of these. And that's maybe what they've done, or maybe they've just left it as that. So let's have a look at what they've done. Okay, so they've got to the same stage as me here. And yeah, so they factorized out, like I said, they factorized out the 4x, the x squared minus 4, and the x cubed minus 1 all cubed. So that's why it's useful leaving things in brackets. And then on the inside, what was left when we took out those factors from the left hand and the right hand term was 3x and x squared minus 4, the left hand one, and x cubed minus 1 on the right hand one. Now, this thing in brackets can be simplified to this thing here if you multiply it out and simplify it. And that's the final factorized form. So this is not wrong, but it's just not very pretty. In terms of an exam question, it might say and simplify, or put it in this form, or even show you the answer. So it depends on the question as to what they require. But it's always good practice to try and simplify your answer. Get down to this thing here, guys. Thank you for listening for that one. I'm going to do the quotient rule next in the next video. Thank you very much, guys.